Hi, and welcome to Mr. Dare's Integrated Algebra Online Review. Today's adventure, Probability Stability 1. Now, if you open up your probability document in your School Island folder, you'll note that mine looks a little different than yours. The questions are all in the same order, so it shouldn't make a difference. Also, you might look and take a notice that some of the questions look exactly the same as a quiz that you just recently took. That's because they are. Let's take a look at some of them, because they're all really good review for the regions. Let's take a look at number 1. Number 1 says, how many different 5-member teams can be made from a group of 8 students if each student has an equal chance of being chosen? Now, for this problem, the key word here is teams. With a team, or when selecting a team, order doesn't make a difference. So, I'm going to use a combination. And then I take a look at the other notes in the problem. We have 8 students, and we want 5-member teams. So the 8's going to go down here, and the 5 down here. Now to do a combination, you can simply just type in your calculator if you really want, or you can do it the longhand version. I'm going to show you the longhand version here. Longhand version requires you to know something about a permutation. A permutation of 8 things taken 5 at a time. Now, the difference between a permutation and a combination is that we have some division to get rid of repetition. We're going to divide this by the 5 factorial, and that just comes from this number right here. So, a permutation of 8 things taken 5 at a time is simple enough to do. The 5 tells me how many lines to draw. 1, 2, 3, 4, 5. And the 8 tells me where to begin. So I start at 8, 7, 6, 5, and 4. Multiplying along the way. Then I'm going to divide by 5 factorial. Now keep in mind a factorial just is starting at the number and working your way down until you reach 1. Again, multiplying along the way. Now you can get some help from the calculator here if you want. I suggest multiplying all the numbers on the top, then multiplying all the numbers on the bottom, and then dividing the two products. However, I'm going to do some canceling out. The 5 can cancel out with the 5, the 4 with the 4, the 3 with the 6, and that turns into a 2. And then the 2 can cancel out with that new 2. The 1 really doesn't make a difference, so we can cancel out 2. And then we're just left with 8 times 7, which is 56. Also in this problem, it's choice 2. Alright, let's take a look at the second problem, which is a little different. Second problem says, how many different 7-letter arrangements can be formed from the letters in the word Genesis? Now, the key word on this one is arrangements. When we are looking at arrangements, order makes a difference, meaning you can distinguish between switching the letters around and not. So, when order makes a difference, we use a permutation to determine the number of arrangements that can be made. So this will be a permutation of, first we see how many letters we have to begin with, and in fact we do have 7, and how many letters we want. We want those arrangements to be of 7 letters. Alright, so simple enough. I'm going to start, draw 7 lines, 1, 2, 3, 4, 5, 6, 7, and I begin with 7 and count my way down. 6, 5, 4, 3, 2, 1. Again, multiplying along the way. However, since Genesis, the word Genesis has some repeated letters. We have an E here, we have another one, and then we have an S and another S. Since it does have that repetition, we have to divide this by the repeated letters. A 2 factorial for the 2 E's, and a 2 factorial for the 2 S's. And that will give us a final answer. Now again, you can do this on the calculator. I would strongly recommend, though, figuring out what this top is, figuring out what this bottom is separately, and then divide the 2 answers. If you don't do that, if you try entering it all in once, you're going to need to put some parentheses on this bottom. Either way, you should come out with the same right answer. So let's see what happens here. I'm first going to clean up that bottom. 2 factorial times 2 factorial is 2 times 1 times 2 times 1. So that bottom really becomes 4. So the 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4. Alright, so that's going to cancel out with that. And then we have to do some multiplication here. So let's see what that's going to be. So if I take a look at my calculator, make sure it's turned on. We're going to have 7 times 6 times 5 times, we don't need the 4, 3 times 2, and then times 1. And we get an answer of 1,260, which is choice 3. All right. Now if we take a look at the third question. Third question in this set deals with the Grimaldis having 3 children born in different years. The probability that the Grimaldis have 3 boys is, and we don't know. So let's take a look at how to solve this problem. One of the simplest ways to solve this problem is just to draw a tree diagram. Now, a tree diagram can be drawn in a number of ways. I typically draw mine going across. A lot of people like to draw them up and down, though. Alright, and what we're going to do is list the possibilities of what the 3 children could be. So the first boy, or the first child, could either be a boy or a girl. These branches represent the first child. Now we're going to draw some branches to represent the second child. The second child could be a boy or a girl once again. And if it's a girl, same options are available for the second kid. For the third child, we would branch these all off again. Boy, girl, boy, girl, boy, girl, and boy, and then girl once again. Alright, what it says here is we're interested in the branch of 3 children that are all boys. So if you take a look, that's this top branch right here. So we're interested in that option. That option of boy, boy, boy occurs only once in this entire tree diagram. So our probability is going to be 1 out of our total number of options. There's 1, 2, 3, 4, 5, 6, 7, 8 different options. So the probability will be 1 out of 8. Alright, question number 4 is another type of probability question. It says, Adam has a bag containing 4 yellow gumdrops and 1 red gumdrop. He will eat 1 gumdrop, and a few minutes later, he'll eat a second gumdrop. Alright, so I know during the quiz, a lot of people ask me, at least the first time taking the quiz, is there repetition in here? And the answer is no. You can't really throw a gumdrop back into a bag after you've eaten it. So this is a probability question without repetition, meaning you can't toss it back in, you can't select it again. So if you eat a red gumdrop, you're not going to be able to eat another one, because there's only one in the bag. Alright, so let's take a look at some of the questions here. The first one says, the probability Adam will eat a yellow gumdrop first and a red gumdrop second is, and we have to fill it in. Now, again, a tree diagram is pretty helpful here. Not the only way of solving it. You can use the and rule of probability if you want. But I'm going to draw a tree diagram. Alright, the question says he could eat a yellow gumdrop first or a red gumdrop. He has 4 yellow gumdrops. So I'm going to distinguish between them. There's yellow 1, yellow 2, yellow 3, and yellow 4. And there's 1 red gumdrop. To see what he eats for the second, so these are all the options for the first. For the second, there's, after he eats yellow 2, he can eat yellow 1, yellow 3, yellow 4, or the red gumdrop. Now I can continue my tree diagram, but pretty much you can see the pattern that's going to go on here. Alright, there are 4 options for this one. There'll be 4 options for eating yellow 2 first, 3 options for following up yellow 3, and 4 options for yellow 4, as well as 4 options after eating the only red gumdrop. Alright, so altogether there are going to be, let's see, so 4, 8, 12, 16, 20 different options. So altogether, my probabilities are going to be out of 20, because there's 20 different options available. Alright, so the first one says the probability Adam will eat a yellow gumdrop first and a red gumdrop second is, well, it occurs once here, It'll occur once down here too, and once here, and once here. So that would be 4 out of 20. Now you could write an equivalent fraction to that, such as 2/10 or 1/5. All would be acceptable. Alright, so there's letter A answered. So let's take a look at question B. Question B says, the probability Adam will eat 2 yellow gumdrops is, and we have to fill in the blank once again. So if we take a look at our startings of our tree diagram, we can kind of figure it out. Alright, so it's really asking the probability of Adam eating 2 yellow gumdrops. Well, on this branch, he has 3 different options. After he eats yellow 1, he can eat yellow 2, yellow 3, or yellow 4. Alright, same thing is true with yellow 2, except you replace y1 with y2. So for each of these yellow branches, there would be 3 different options. So 3, 6, 9, 12. And we're still out of the 20 total options for the entire system here. So it would be 12 out of 20. So again, you can simplify this a bit. You can divide both these by 4. In that case, you'd end up with 3/5. Alright, for letter C. Letter C is a little tricky because we can have 2 different situations occur. It says the probability Adam will eat 2 gumdrops having a different color is, alright, so if I take a look, each of these yellow branches is going to have a yellow followed by a red. So there'll be 4 total there. So yellow, then red, there's 4. However, you have to also consider the red. Suppose I eat the red first, then that could be followed up by yellow, 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 and yellow. So yellow 1, 2, 3, or 4. So there's 4 additional options. So altogether, there's 1 for each of the yellows, so there's 4 there, and then there's 4 for the red. So altogether, there are 8 different options for eating 2 different colors. So that's 8 out of 20 once again. So if I simplify this, I can divide them both by 4 once again. You'd end up with 2/5. Alright, the last probability asks us to figure out what is the probability of eating 2 red gumdrops. Now this one may seem a little ridiculous because there's only 1 red gumdrop. In fact, that means the probability of eating 2 of them would be 0 out of 20. It can't happen. It's also 0 or 0%. All of those are the same thing. So, looking back at this question, it's all about probability without repetition. We're not throwing things back in. They can't be selected after you've selected them once. And drawing a tree diagram is probably the most useful way of solving this. Alright, question number 5 deals with the fundamental counting principle of mathematics. The fundamental counting principle of mathematics is a fairly simple, easy tool to use. It's all about finding the number of choices you have. Here it says I have 5 sandwiches, 3 salads, and 3 beverages. How many different meals can be chosen of 1 sandwich, 1 salad, and 1 beverage? Fundamental counting principle says to figure it out quickly and easily, you just take the number of choices and multiply them all together. We have 5 choices for the first thing, 3 for the second, and 3 for the third. So all we have to do is multiply here, and we should get 45, which is choice 4. Alright, question number 6. Question number 6 deals with the complement rule of probability. Complements of probability just really figure out what the chances of something not happening are. Now it's really easy to determine because the probability of something happening and the probability of something not happening always equal 1 when you add them together. That's the fundamental complement rule of probability. So what I'm going to do is take a look. I have 0.7 chance that it will rain. I want to figure out what is the probability that it won't rain. What this means is, if I change this to a fraction, 7/10, 7 out of 10 days it will rain. So the fact that it won't rain will occur on 3 out of those 10 days, which is the same thing as 3/10, which is choice 1. And in fact, if you add 0.3 to 0.7, you get 1. Alright, question number 7 says, what is the greatest number of 2-letter arrangements can be formed from the letters in GRADE if each letter is used only once in the arrangement? Alright, so for this one, we can either use combination, or excuse me, not combination, but permutation, or we can use fundamental counting principle. I'm going to use fundamental counting principle here. Alright, I have 5 letters to choose from to begin with, so a 5 will go on my first line. That's the total number of options I have for my first letter. For my second letter, since I've already used up 1, I'm going to be down to 4. If I multiply those two together, you end up with 20 different options there. Alright, now, since we've gone through all these problems, most of the other questions in this section are pretty much the same. The questions will change, but the ideas are all the same. So, you should be able to figure them out. If you have questions, let me know. Alright.